In this video, we're gonna talk about the vector function. This one gonna be very easy and it's gonna be like doing calculus 1 3 times. It's because of you are dealing with the function in only one variable. So you suppose x, y, and z gonna be the function that with the parameter t, and you're gonna have x equal to ft, y equal to gt, and z equal to ht. So you see that you have three functions in one variable, and you're gonna use these three functions to construct the thing that called the vector value function. The vector value function turned out to be the vector rt, so it's going to be the function name is r, and you see that you have ft as your first component, and gt as your second component, and ht as your third component. And when you have this triple x, y, and z, this guy turned out to be give you the position. So this guy RT is gonna mean that at t equal to t, you're gonna get the position. So it's gonna be P, or the point here that we use. So you see that this guy is gonna give you position or point in three-dimensional at the time t. Okay, so this one will give you the position of point in three-dimensional at the time t. So this one is going to be given by the vector ft, gt, and ht. For example, you see that rt equal to t squared. So you see that this guy turned out to have only two components. So it's going to be t and t squared. And if you like to plot this function. So when you like to plot this function, so you can like compute r at -1. At -1, you see that it's gonna be the point that you have -1, so it's gonna be -1 square, so it's gonna be -1 1, and r at 0. Let's compute r at 0, so you see that it's gonna be at the origin, and r at 2 is gonna be 2, and 2 square, so it's gonna be 4. So this one is gonna give you just a rough idea where the position of the point that follow the function r would be. However, when we like to plot this one, the thing that we're gonna try to find is gonna be, we're gonna try to find the coordinate in terms of x and y. So you see that you're gonna have the first one turn out to be x, and the second one turn out to be y. So you have x equal to t and y equal to t squared. So what does it mean? It means that you can relate x in terms of y, or y in terms of x. So as you can see here, you have x equal to t, y equal to t squared. So you're gonna have y equal to x squared. Okay, so you have y equal to x squared from these two relations. So you have y equal to x squared. And when you have y equal to x squared, so it's going to be, you're going to have y equal to x squared, and you plot from -1 less than or equal to x less than or equal to 2. Why do I have that? Because you see that this one x equal to t. Let's put t first. Let's put t here first. So when you put t here, and here is going to be your x. Okay, so it's going to be x between -1 and 2, because t equal to x, as you can see from the yellow guy. Okay, so you're going to plot y equal to x squared from -1 to 2. So what it's going to look like it's gonna look like that. You're gonna get parabola. So this one is y, this one is x, and y equal to x squared gives you a parabola like this. Okay, so it's gonna be a parabola. Okay, so let me try to draw a parabola. So it's gonna be a parabola. So you have this parabola y equal to x squared, but it's not gonna be the whole parabola because we like only the parabola that taken the value from -1 to 2. So it's gonna be -1, 1, and 2. Okay, so you have 2 equal to 4 like this one. So you would just erase the rest of the graph. Okay, so you don't care about the rest of the graph. So basically you care only from -1, which is you're gonna have the height equal to 1 and you're gonna have 2. Okay, and you see the point of the parabola that you have before. So you have the point 2, 4, you have the point 0, 0, and you have the point -1, 1. And you see that the way that you have t will increase from left to right. Okay, so t will increase from left to right. So your curve will gonna have like the trace in the way that you're gonna use some arrow to indicate the direction of moving or the direction of the movement of the point. So this one gonna be indicated by the arrow. So this one used to indicate the movement of the curve or the movement of the point according to the function RT. Okay, so it's gonna be like you use small arrow here to indicate the movement of your vector value function. Okay, so this one will be, you're gonna see that it's gonna be moving from -1 to 2, okay, from the direction that it's gonna be from the left to the right side. Okay, so this one is gonna be just, you convert from the vector value into the function that you be able to know the graph. The next one, you have RT equal to 2 cos t and 2 sine t. And you like to sketch when t between 0 and 2 pi, and you like to sketch when t from pi over 2 to 3 pi over 2. So in this case, you're gonna use the same trick like we did before. So you're gonna have x and y for each guy. So you have x equal to 2 cos t and y equal to 2 sine t. Okay, so you have x equal to 2 cos t and x equal to 2 sine t. And you're gonna have x squared plus y squared. So this guy will be 2 cos t squared plus 2 sine t squared. So you get 4 cos squared t plus 4 sine squared t. Okay, and you see that this guy will be 4 and it's going to be cos squared plus sine squared, and this one become 1. Okay, so this cos squared plus sine squared turn out to be equal to 1. So it's going to be just 4. So this will give you x squared plus y squared equal to 4. Okay, and so this will have the graph circle. Okay, center at the origin. And you have radius equal to 2. Okay, so you have the radius equal to 2. So we're gonna graph this one. Okay, so we're gonna graph this one in this way, and you're gonna just have the whole circle. Okay, so you get this circle. How would I know that it's going to be whole circle or not? It's going to be not whole circle. It depends on your t. So for t equal to 0, okay, so t equal to 0, you would get r0 equal to 2, okay, and 0. Okay, so when you plug in t equal to 0, cos 0 equal to 1, sin 0 equal to 0, so it's going to be r0 equal to 2. Let's compute r pi over 2. R pi over 2 is going to be 0, 2. So in this case, you get 2, 2, negative 2, and negative 2. So this one is the circle radius 2. And you see that you're going to begin at t equal to 0. And t equal to 0 is here at 0, 2. And at this point, it's going to be t equal to pi over 2. Okay. And at this point, it's going to be t equal to pi. And at this point, it's going to be t equal to 3 pi over 2. Okay, so it's going to be like the point on the x and y axis respectively. And you see that you're going to have t from 0 to pi over 2. The meaning will be you are moving along the curved circle here, along the circle here until you get a full round. Okay, so it's going to be one round like this one, and you would stop at 2 pi, so which is here. So this one is going to be the point where you have t equal to 2 pi as well. So it means that you're going to get a full round. So we're going to put a small arrow to indicate our direction or our movement, okay, in the circle that you have here. Okay, so it's going to be one round along this circle. Okay, it's going to be one round along this circle. Okay. However, for B, you see that you are having from t equal to pi over 2 to 3 pi over 2. So this one will be just, you have the whole circle again. Okay, so let me draw the whole circle. Okay, same as before. Okay, so you have the whole circle here. However, the whole circle here is going to be 0 to 2 pi. But you would just need only t equal to pi over 2 to t equal to 3 pi over 2. Okay, so you see that you're gonna start at pi over 2 and you're gonna move along this circle, okay, along the graph of this circle until you reach 3 pi over 2. So the thing that you're gonna have is gonna be only the red curve here that is gonna be running from t equal to pi over 2 to t equal to 3 pi over 2, and you would stop here. So in this calculation, you're gonna stop here and you're gonna erase the rest out. Okay, so you're gonna just erase this guy out. Okay, and you're gonna just use a small arrow in order to indicate that you have this guy and to this guy. Okay, so it's gonna be from t equal to pi over 2 to 3 pi over 2. Okay, so this one is going to be for question B. Okay, so that is going to be for the second one. And for the third one, you have r equal to cos t sine t and t, where t positive. So this one is going to be helix. So you see that this one you're going to begin at 0. Okay, so R0, this guy turned out to be cos 0, sine 0, and 0. So it's going to be 1, 0, 0. Okay, and if you have pi over 2, so it's going to become 0, 1, and pi over 2. At pi is going to become negative 1, 0, and pi like this. So you see that you're gonna have the movement in three-dimensional. So it's gonna be from the floor, which is z equal to 0, to z equal to pi over 2, and to z equal to pi. So you see that you're gonna get kind of a circle or something like this. It's gonna be cylinder. However, the cylinder is gonna be just our guideline for the movement. The movement turned out to be just something like this. It looks like spring or this thing in math is called helix. Okay, so this is going to be helix. This one is also the shape of your DNA. Okay, so it's going to be the shape of the DNA. Or if you go to what's it called, M quartier, you're gonna see that on the 7, 8, 6, 4, it's gonna be the stair that is not going to be stair, so it's going to be helix that you can move from the 6 to the 8 without have to walking on the stair. So that one is going to be look like this shape. Okay, so you go to M quartier and you see that. So this one. Okay, so it's going to call helix. Okay, and this one will have the shape like this. The cylinder used just for the guideline in order to sketch the helix. Okay, so the helix is going to be just this curve. Okay. When you have the vector value function, it's going to be like you do calculus 1 3 times. So it's going to be you have the function f, g, and h. You'll be able to find the limit x go to, limit t go to a of this function because t is going to be just variable here. And you see that you'll be able to take the limit. And the way to take the limit turned out to be just you're gonna compute the limit term by term or component wise. So you have the first component, second component, and the third component. So when you like to compute the limit, so it's going to be just the limit of the first, the limit of the second, and the limit of the third component. Okay, so it's going to be in this idea. The derivative gonna happen in the same way. So you'll be able to find r prime t. So it's gonna be the derivative of each component. So it's gonna be derivative of the f, g, and h. Okay. And also for the integral. So the integral turned out to be the integral for f, g, and h. Okay. And you'll be able to compute the definite integral from a to b. Okay, so it's going to be on each guy. So it's going to be on f, on g, and on h. So like I said before, it's going to be like you're doing the calculus 1 3 times. Okay, so everything that we study in calculus 1 is going to be applied for this one. So it's going to be like doing calculus 1 3 times for each question. Okay, and you have derivative formula, derivative of constant multiple, derivative of the sum of function, product rule, okay, quotient rule, and anything. So it's going to be applied for this one. Okay, so we're gonna let's discuss one thing. It's going to be about the meaning of doing derivative. Normally, when you do the derivative, it's going to give you the tangent line. Like in calculus 1, you see that you're going to have the thing that called the tangent line when you do derivative. So in this case, it's going to be also the tangent line. However, it's going to be the line that happen in three-dimensional. So this one, I'm going to say that r prime t will give you the direction vector. Okay, so it's going to give you the direction vector of tangent line. Okay, so it's going to be direction vector of tangent line. So when we are doing the line in 3D, okay, so it's going to be the line in 3D. The line in 3D, you're gonna need what? You're gonna need, it's gonna be X, Y, Z. Okay, so it's gonna be X, Y, Z, and you're gonna need the point X0, Y0, Z0, and you're gonna plus by T, and you're gonna have A, B, C. Okay, so this one is the equation of line, and this guy is the thing that I said here. It's going to be the direction vector. Okay, so it's going to be direction vector. Okay, so let's do this one. You have t equal to the function 1 minus e to the t over t 1 over 1 plus t square and secant square t. So for seeing this one, you see that you have three functions: the first component, the second component, and the third component. The question asks you to compute the limit t go to 0 of this function. So it's gonna be, you're gonna take the limit by doing, you're gonna take the limit to each term. So it's gonna be limit t go to 0 of 1 e to the square root t over root t, limit t go to 0, 1 over 1 plus t square, and it's gonna be limit t go to 0 secant square t. Okay, and you're gonna have just compute this limit. So you see that here you're gonna get 0 over 0, and the thing that you're gonna do is gonna be, you're gonna use L'Hopital. So for compute the first limit, it's gonna be using L'Hopital. So it's going to be limit t go to 0. Okay, limit t go to 0. And in order to use L'Hopital, you're going to dip on top, dip on the bottom, right? So this is going to be, you dip e to the negative t. So it's going to be negative e to the square root t, 1 over 2 root t. Okay, so we are doing calculus. And when you dip square root t, it's going to be 1 over 2 root t. Okay, and you're gonna just cancel these two. Okay, so this one will become negative e to the 0, so it's gonna be negative 1. Okay, so this is gonna be the first term. The second one is going to be, you have limit t go to 0, so it's going to be 1 over 1 plus 0 square, okay, without using any L'Hopital. So it's going to be 1, okay, and you're gonna have the last one, which is limit t go to 0 of secant square. So this one becomes secant square 0, and it's going to become 1 also. Okay, so this guy will turn out to be this limit, and it turned out to be this vector, okay, negative 1, 1. The next one, you have prime t, okay, so you're gonna just differentiate the blue guy, the gray guy, and the orange guy. So it's gonna be, you're gonna differentiate term by term. The first one, you need to use the quotient. Okay, so this was the first one. You see that it's going to turn out to be the quotient rule. So you're going to dt of 1 minus e to the square root t over square root t. Okay, and the second one is going to be dt of 1 plus t squared to the negative 1. Okay, and the last one is going to be dt of secant square. Okay, and you differentiate, so it's going to be the bottom derivative of the top. Okay, so it's going to be the bottom derivative of the top. So it's going to be the bottom derivative of the top. So it's going to be negative e to the root t times 1 over 2 root t. Okay, minus the top derivative of the bottom. and everything will be over the bottom square. Okay, so it's going to be this. And for the second one, let me highlight this guy a little bit in order to distinguish. Okay, and for the second one, it's gonna be -1. Okay, so it's gonna be -1 over 1 plus t squared. Let's do slow. So it's gonna be -1. Okay, and you have 1 plus t squared to the -2. Okay, and you dip t squared, so it's gonna be 2t. Okay, so that is going to be the second one. So it's going to be my second one. Okay, and finally for the third one, okay, let's move this guy a little bit. The last one is going to be dip sec square is going to be 2 sec t. Dip sec is going to be sec t tan t. Okay, so it's going to be 2 sec t tan t. So this one will be just, okay, so this one is going to be the last one. So it's going to be the orange one. And this one will be your answer. So you may or may not simplify this one. Okay, so if you like to simplify, you may just have negative e to the root t over 2 minus 1 minus e to the root t over 2 root t over t. Okay, and you have negative 2t over 1 plus t square, and you have 2 sec square t tan t. Okay, so this one will be just 3 terms answer. Okay. Okay. The next one, you have integrate. Okay, so you're gonna integrate. So it's gonna be integrate term by term or component by component. So it's gonna be 1 minus e to the root t over root t dt integrate 1 over 1 plus t squared dt and integrate sec square t dt. Okay, so that's gonna be my first, my second, my third. Okay, and you're gonna have this integral, so it's gonna be integral 1 over root t e to the root t over root t dt, and you have integral 1 over 1 plus 3 squared, so it's going to be just arc tan t, and integrate sec square is going to be tan t. Okay, and here when you integrate, you're gonna plus some constant. Okay, so I'm gonna have to plus c2 and I'm gonna plus c3. I'm not gonna plus c with the same c because they come from different function. Okay, and the way that I'm gonna plus is gonna be plus c1, c2, and c3 respectively. Okay, so for the first one, we're gonna have to take care of this guy separately, and you have integrate 1 over root t. Last semester is going to be 2 root t. Okay, so integrate 1 over root 3. So it's going to be 2 root 3. and you need to integrate. So you're going to use the substitution e to the root t over root t dt. So you would just let u to be root t, and you have du equal to 1 over 2 root t dt that I tried to explain last semester. So it's going to be 2 du equal to 1 over root t dt. Okay, that is called the integration by substitution. And you see that this guy turned out to be integrate e to the u times 2 du. So it's going to be 2 e to the u plus c. So it's going to be 2e to the root t plus c. And this will be 2e to the root t plus c1. Okay, so that will be your final answer. Okay, so this will be just the final answer for this one. So you see that it takes long a little bit to work this one out because it's going to be like doing 3 questions in calculus 1. Okay, so you have to like take care the function separately. Okay, so this one is the gray one, this one is the orange one. The next one, okay, we have t equal to, okay, so I have double, so let me erase one out. So I have t equal to 2 cos t sine t to t plus 1 times k. So it's gonna be ijk. So you see that this one will be your first, your second, and your third component respectively, similar to the representation in terms of bracket or angle bracket that we had earlier. So you have R prime t, we like to find R prime t, and we like to find parametric equation for the tangent line to the curve t equal to 0. So in order to find the tangent line, okay, so we need to find the tangent line. Okay, so we need to find the tangent line. It means that you're gonna need R prime at 0. Okay, and this one will be direction vector. Okay, so this one will be direction vector. So you're gonna begin by finding R prime t. So you have R prime t, so you're gonna dip 2 cos, it's gonna be dip cos is negative sine, so it's gonna be negative 2 sine t. Dip sine, you get cos t, and dip 2t, so you get 2. Okay, so that R prime t, and you're gonna have 0. So it's going to be negative 2 sine 0, cosine 0, and 2. So it's going to be, okay, so forgive me that I don't want to erase it. I should erase it. Okay, so it's going to be this one. I should use angle parenthesis. Okay, so it's not going to confuse you on this one. Okay. So you have 0 equal to 0, 1, and 2, okay? And you like to know 1 point, okay? Point, so that the 0 for direction maker, so the point is going to be just at any point. So let just use the point r0. Okay, so it's going to be the value of r at 0. So it's going to be 2 and sine 0 is 0 and it's going to be 1. So it's going to be 2, 0, 1. Okay, so the point will be 2, 0, 1 and you have prime 0, sorry, prime 0 equal to 0, 1, 2. So in this case, the line that we are looking for, okay, so the line that we are looking for turn out to be, you have x, y, z. Okay, so it's going to be x equal to, y equal to, and z equal to. So it's going to be xt, yt, and zt in order to be the parametric equation. And you're going to have the point 2, 0, 1. Okay, and you would just add by the green one. So it's going to be 0, 1, 2. Okay, so it's going to be t. Okay, so it's going to be xt equal to 2 equal to t equal to 1 plus 2t. Okay, so that is going to be the equation of line in 3-dimensional. Last one, we like to integrate from 0 to pi over 2 of t. So for this one, okay, so for this one, you have integral from 0 to pi over 2 of integral 0 to pi over 2 of the first function is 2 cos, okay, so it's going to be 2 cos t psi t, and you have the final one is 2t plus 1 dt. So you're gonna just have this guy, and this guy. So you would get integrate cos, you get negative psi, so it's gonna be 2 psi t. Okay, so that is gonna be 2 psi t from 0 to pi over 2. Okay, this is the symbol or the notation that we use in Cal 1. Indicate indicate cos, you get psi, not negative psi. Indicate psi, you get negative cos from 0 to pi over 2, and integrate 2t plus 1, so it's going to be t squared plus t from 0 to pi over 2, okay? And this guy will be equal to this. And this would give you 2 psi pi over 2, 2 psi 0, and it's going to be negative cos pi over 2 minus cos 0. Okay, so that will be the first term, the second term, and finally the third term. So it's going to be pi over 2 square plus pi over 2 minus 0. So this one is the blue one, the gray one, and the orange one. So it's gonna be 2. Okay, so it's gonna be 2 for the first guy, and the second guy will be 1. Okay, so this guy becomes 0, this guy become 1, this guy become 1, this guy becomes 0. Okay, and you get the final term turn out to be pi squared over 4 plus pi over 2. Okay, so this would give you just the term that you have here. Okay, so I have the correct answer. Okay, so that will be for the vector function. Okay, I'm gonna we're gonna have only this topic for chapter 13 that we're gonna cover. We're not gonna cover anything more than this one. The last topic that I will teach you will be the distance. The distance means that when you have or when you move along this curve, so when you are moving, like you have a particle that move along this curve, you like to know the distance of the movement that you have. Okay, so you like to know the distance when you like to walk along this curve to this curve, or when you go to M Quartier, you like to know when you walk from the 6th floor to the 8th floor, what is the distance that you have? Okay, so it's going to be the thing that we call the distance or the arc length. Okay, so it's gonna be the length of the arcs. Okay, so it's gonna be the length of the arc of a t from A to B. Okay, so if you are moving from A, so it's gonna be A here to B, and you like to know how long or how far that you move along this curve from A to B. Okay, so it's going to be LAB. Okay, so the notation is kind of the same of the arc length that we studied last semester. So you have AB equal to integral from A to B of the norm of R prime T dt. Okay, so it's going to be norm of R prime T dt. So in order to find this one, it's going to be a particle move in three-dimensional space as the vector value function rt equal to this one. We like to find the distance when the particle move from t equal to 0 to t equal to 2. So this distance turn out to be arc length. Okay, so it's going to be arc length. So it's going to be L02 is going to be integrate from 0 to 2 of norm of r prime t dt. Okay, so it's going to be norm of r prime t dt. So let's find r prime t. So for r prime t, you need to differentiate term by term. So this would give you 12t. Okay, so it's going to become 12t. And 12 square root 2 t square. Okay, so it's going to be 12 square root 2 t square. And the finally is going to be 12 t cubed. Okay, so that would be it. Yeah. Okay, so this one. Okay, and then you're gonna just evaluate the integral. Okay, so you have r prime t equal to this one. So let me move this term down here. Okay, so you have r prime t equal to this one. So you're gonna compute norm r prime t. Okay, norm r prime t turn out to be square root of 12, okay, t square plus 12 square root 2 t square, okay, then square, and it's gonna be 12 3 cube square. Okay, so this one will be just okay, I cannot, okay, it's gonna be almost straight line. So you see that you allow to move 12 square outside, so it's gonna be 12 square. Okay, and you have t square. I'm gonna mess up. So it's going to be square like this. Okay, so you see that you distribute square to 12. Okay, so you distribute this guy. So you see that it's going to be 12 square, and here it's going to be plus, the second term will be plus 2t to the fourth, and the last term will be t to the sixth. Okay, so it's look like this one, and then you see that it's going to be 12 square, and you get t square 1 plus 2t square plus t to the fourth. Okay, and you see that when you take square root, so it's going to give you 12 times t square root, and you see this yellow guy here, 1 plus 2t squared plus t to the fourth. This guy is a complete square equal to 1 plus t squared square. Okay, so it's turned out to be the term that you need to recognize. So it's going to be 1 plus t squared square inside square root. So this would give you 12t 1 plus t squared. Okay, so you're gonna have this calculation so far. Okay, let me make this guy smaller a little bit. Okay, so you have the first step and the second step. You get 12t plus t squared, and this one become 12t plus 12t to the third. Okay, so it's going to be that term, and then this one is your formula, and the second step will be your R prime t, and the third step will be you're gonna have L0 to turn out to be integrate from 0 to 2 of 12t plus 12t cubed dt. So it's going to be 12t squared over 2 plus 12t to the fourth over 4 from 0 to 2. So it's gonna be 6 2 square plus 3 times 2 to the fourth. Okay, so it's gonna be 2 to the fourth, and you have minus 0, and you're gonna have to calculate this messy number. So it's gonna be 24 plus 48, so it's going to be 72. Okay, so the distance turned out to be 72 units. So you see that this fall into the difficult of algebra. So everything so far is going to be calculus at this line and calculus at this line. The rest turned out to be just algebra. Okay, so it's turned out to be difficult because of the algebra. Okay, finally. So for this example, you're gonna have to find the length of the arcs of the circular helix from the vector function rt equal to cos t, sin t, and t. So first of all, you have the point 1, 0, 0 to the point 1, 0, 2 pi. So here you see that it's gonna be just one floor up from this picture. So you have this one and you are walking along this helix. So it's going to be pi over 2. Okay, so it's going to be 3 pi over 2, and you're going to stop here. So it's going to be one floor up for walking in this helix. So in this case, you see that you're going to begin at t. Okay, so the final term here, okay, or the final component turn out to be your t, okay, so you see that you have tk, and this guy gonna tell you t and t, okay, so it means you have t equal to 0 to t equal to 2 pi, okay, and you need to compute r prime t, okay, so you need to compute r prime t, and you're gonna have L0 pi, okay, find r prime t, and you find norm r prime t, okay, and you're gonna compute integrate from 0 to pi of norm r prime t dt, okay. I'm gonna let you try to do this one on your own first, and then I'm gonna give you the solution during the recitation, okay? And that would be it. And you have exercise 13.3, question 1 to question 6 in order to practice for this one, okay? And that would be it for this quiz and this lecture and this clip, and it's gonna be only these 3 topics, so 13.1 to 13.3 for the vector function. We're not gonna have 13.4 and 0.5, okay, so we're not gonna cover them, so it's gonna be just 0.1, 0.2, and 0.3 that I already covered in this lecture. Okay, so that should be all.